Tidal power has long been heralded as a promising renewable energy source, yet it has struggled to compete with solar and wind in terms of cost and scalability. This episode of Tomorrow's Ordinary, the Future Audit investigates whether tidal power can finally break through and become commercially competitive. Drawing on expert insights and real-world examples, we examine the technological and economic hurdles that tidal energy must overcome, and whether the current wave of innovation is enough to make it a viable option for the future. We will explore the potential of tidal turbines, the role of state-backed energy companies, and the lessons we can learn from floating wind projects. The conclusion will offer a grounded scenario of what tidal power might look like in the everyday lives of ordinary people. Can tidal power overcome its historical challenges and become a commercially viable energy source in the near future?
To become commercial?
About 4 or 5 megawatts of installed capacity per machine, because basically the fixed overhead costs of doing anything offshore are very high, and it's...
What does it take for tidal power to become commercially viable? The answer may surprise you. Tidal stream turbines typically have capacities of 1–2 megawatts, significantly smaller than offshore wind turbines. According to a 2023 report, achieving commercial viability may require larger installations. In the future, tidal power could become a reliable energy source for remote coastal communities. Imagine a world where high upfront costs are offset by the consistent energy supply from tidal power. This scenario depends on significant technological and economic advancements that are not yet in place. Despite the potential, tidal energy faces higher capital costs and limited economies of scale compared to wind and solar.
And the analysis we've done suggests that the 4 megawatt machine will instantly be profitable and will make in fact it'll be extremely profitable because there's a very high subsidy.
Could a 4 megawatt tidal turbine be instantly and extremely profitable? Let's explore the factors that might influence this claim. Recent advancements in tidal energy technology, such as improved turbine efficiency and remote monitoring, have increased the reliability and performance of tidal turbines. The tidal energy market is projected to grow significantly, with the market valued at $0.5 billion in 2024 and expected to reach $1.8 billion by 2034. In a remote coastal region with high energy demand and limited grid access, a 4 megawatt tidal turbine could generate significant revenue by selling energy at a premium. However, long-term profitability would depend on consistent energy prices and minimal maintenance costs, which are not always guaranteed. Hybrid renewable energy systems are becoming increasingly important, combining tidal generation with offshore wind and battery storage to deliver continuous electricity supply. The profitability of a 4 megawatt tidal turbine is not guaranteed and depends on various factors, including energy prices, maintenance costs, and the efficiency of the turbine.
Unbuilt until today. GB Energy calls itself an activist investor, chasing down the frontiers private capital moves too slowly on. Deep water wind, long duration.
State-backed energy companies may be key to unlocking tidal power's potential. Tidal energy has the potential to provide 11.5 GW of electricity to the UK, with system benefits estimated at 2 BN/year. As of 2024, over 120 MW of tidal stream energy is projected to be built by 2029. If state-backed companies were to invest in tidal power as part of their broader renewable energy strategy, it could help accelerate the commercialization of tidal energy. This might involve funding pilot projects or supporting the development of tidal stream arrays. Such involvement could help reduce costs and improve the scalability of tidal energy technologies. The UK government has invested in expanding tidal energy R&D infrastructure, including support for the European Marine Energy Centre, EMEC, to enhance tidal test facilities.
Are aiming to build gigawatt-scale offshore wind farms, and before they want to do that, they want to do pre-commercial phases, 100 megawatts.
As floating wind farms expand, what lessons might tidal power take from their journey? Floating offshore wind farms are being developed globally, with gigawatt-scale projects demonstrating the potential for large-scale deployment. These projects require significant investment, planning, and innovation in mooring systems and supply chains. In the future, tidal power could integrate with floating wind farms, sharing infrastructure and reducing costs. This hybrid approach might help tidal energy overcome its unique challenges, such as the need for predictable energy generation. By leveraging existing offshore wind infrastructure, tidal power may find a more viable path forward. While floating wind is advancing, tidal power's future integration remains speculative and requires further innovation. Tidal power is at a crossroads. While the technology has made strides and the economic models are beginning to take shape, it still faces significant challenges, particularly in terms of scale and cost. The evidence suggests that tidal power could become commercially competitive, but only if it continues to evolve and benefit from the same kind of investment and innovation seen in other renewable sectors. A plausible future scenario might involve tidal power being integrated into coastal communities, providing a reliable and predictable energy source that complements other renewables. However, this will require sustained effort, collaboration, and a willingness to learn from past failures. The verdict on tidal power's commercial future remains open, but the signs are encouraging.